Alright, so this is Unit 5, Day 4, Factors and Factoring the Greatest Common Factor. The essential question that we are going to have is going to be, what is a greatest common factor, and how can we start the factoring process using the greatest common factor? Just to let you guys know, you need to be on these notes right here. It's going to say Unit 5, Day 4, and the topic is going to be Factorings and Factoring GCF. So, what is factoring? Factoring is a method to find the basic numbers and variables that make up a product. So another way to look at it is you've got factor equals the product. Think of it also like binomials, so this could be a binomial times a binomial to get the final product, the final thing that we have. Some numbers are prime, meaning that they are only divisible by themselves and 1. These cannot be factored. So when we're talking about prime numbers, I just want you to go back to what some of our prime numbers are, such as 1, 5, 7, 11, and stuff like that. So, what is a greatest common factor? The greatest common factor, according to our notes, is the greatest factor shared by 2 or more polynomials. Always try this factoring method first before any other method. Divide out the greatest common factor number / amount of a variable from each term. And here's a couple of examples that we have. So we're going to take a look here at A, where it says, what is a common factor between 2 and 6? Well, the greatest common factor for that is actually going to be 2, because if I take 2 and I take 6 and see what they have in common, it will just be 2. So if I divided 2 by 2, I'd get 1, and if I divided 6 by 2, I'd get 3. B, we have negative 25 and negative 40, and if we try to work out the greatest common factor, that would be negative 5. Why is it negative 5? Because both of these are negative, so keep that into account too. Always watch your signs. C, we have 6 and 18, and if we factor those out, we would get 6. And then we've got 16 and 32. Take a moment to see what they might have in common, and they are going to have 16 in common. After that, we're going to take a look at E, which is our last one, and it's 3 and 8. I want you to try and figure out what 3 and 8 have in common. And it's just going to be 1. That's all they have in common. Because there's nothing that goes into 3 that would also go into 8. If there is no greatest common factor and it's trying to ask you what it's going to be, it's just going to be 1. So if you get something that's prime, just put in 1. So greatest common factors, so we're going to look at this with variables, and the reason that we're doing this with variables is because you're going to be doing this a lot with binomials and trinomials. So we'll take a look at letter A, and it says x and x squared, what do they have in common? X. Number 2, what do they have in common? X squared. And then we'll take a look at C, what do they have in common? XY. And then if we take a look at 2x to the third and 8x to the square, what's that going to be? It's probably going to involve a number and a variable, and that's going to be 2x squared. And then we've got 3x to the third and 6x to the second, and those are going to have both a number and a variable in common, and that's going to be 3x squared. And then we have 4x squared and 5y to the third. So again, what do they have in common? They don't have anything in common, so it's 1. Again, remember, if there is no greatest common factor, and it's trying to get you to state what it is, you just put in 1. Alright, so let's see. When we have to factor out the greatest common factor, it means that we're trying to divide out a number. And the reason that we're doing that is because sometimes we have very large numbers and we're just trying to work out a way to keep them small, just neat and tidy, something that we can easily work with. So we have 2x plus 4y. I don't have a variable in common, but 2 and 4 have something in common. So I can divide 2 out by both of these, and I would rewrite it as 2 times x plus 2y, as you see right here. Again, we'll take a look at 5a minus 5b, and that is actually going to be, the greatest common factor will be 5. So I would rewrite that as 5a minus b. And again, I've got 18 and 6. I have an x and a y, so I don't have a variable, but I do have a 6 in common, so I'm going to rewrite that as 6 times 3x minus y. And then I've got 2m plus 2mn. And I can factor out a number and a variable because that's what they have in common. So I would factor out 2m to get 1 plus 2n. And then the last one that we have here for our examples is 5x squared y minus 10xy. And if I had to take a look right at that, I see that I have 5x and a y in common. So I would divide all that, and I would have 5xy times x minus 2. And then how can you check? The easiest way that you can check is to really distribute this back into what you've already done. So if we take a look here, if we're factoring out the greatest common factor, so we have looks like a trinomial here. So we got 15xy squared minus 10x to the third times y plus 25x. I don't even know if this is in standard form. That's my first complaint. But anyway, let's see. We have to factor out what is in common for each term and put in the front and see what we have left over. So we have 15, 10, and 25. So I probably have something that's going to be in the 5 range. And I also see that everything has an x and it has a y. So I'm going to factor out a 5xy. So let's take a look here. So there's my 5xy. And I'm going to times it by 3 and 2x. Yep, that looks right. So it says that we are going to check our answers by distributing it, as we have talked about before. So if I go and I take this and I apply it to everything inside, I should still get the exact same answer I started with. So here we go. We're going to take out the greatest common factor for 2x. Let's see, 8x, 4x, 6x. I can definitely take out an x, and I can take out a 2. So let's see what I've got. Yep, 2x, and that's going to be timesing x third minus 4x to the square plus 2x minus 3. So yeah, and then I would take that and distribute it to see if I get the exact same answer. Distribute. And now we're going to do some practices, and just to let you guys know, on our notes, we should be on the second page right here, right now, where it says example 1 practice. So I want you to distribute the 15x squared minus 5x and see what you get. And if you went ahead and you pulled out the greatest common factor, you should have gotten 5x, like so. And then you can rework the problem to be 5x times 3x minus 1. So we'll go on to example 2. And example 2 is 8x squared minus x. And I can only take out, looks like an x. So I take out my x, and then I rewrite my problem to be x times 8x minus 1. So yes. Always remember that there's an invisible 1 in here, so when you guys are looking for the greatest common factor, you can take x out and replace it with 1. Remember, if it can't, remember that you can always do that. It's super easy. And then our third, and it looks like, I want to double check, and our third example is going to be 8x squared, yx to the 4th, plus 2x cubed, y to the 5th, minus 12x to the 4th, and y squared. So let's say I've got 8 to 12. The only coefficient I have in common is going to be 2. I can take out a 2x from each side, and I can also take out a 3y. So I'm going to rewrite this as, I'm going to write down my greatest common factor as 2x2, 3y, and I'm going to rewrite my problem as 2x times 4y plus y to the square minus 6x to the square. So yeah, that looks right. And I can double check that by distributing this to every one of these terms, and I should get this exact same answer that you see here on the top. So that brings us to our summary, which is where we have to answer our essential question of what is the greatest common factor and how can we start the factoring process using the GCF. Please take a moment to make sure that you have this filled out on your notes. This is worth points.